All right, let's dive into one of the wildest, most successful theories humanity has ever come up with, quantum field theory. It is the absolute foundation of modern physics. But as we're about to see, it really makes you stop and ask, what on earth is reality anyway?
You've probably heard that quantum physics describes, the fundamental building blocks of the universe. But what if that's not the whole story? What if our most powerful, most precise theory isn't some perfect photograph of reality, but is actually more like an incredibly powerful tool we've built to poke and prod at it?
A calculator. Think about that word for a second. Your calculator doesn't tell you what the number 2 times is, in some deep philosophical sense, but it gives you the perfect answer when you ask what's 2 plus 2. This whole idea suggests QFT is less about what reality is and way more about predicting what we'll see when we decide to look.
And this gets us to a really classic and, frankly, crucial idea, the difference between the map and the territory. Our scientific models, they're the maps, unbelievably good, detailed maps. But they are not the territory itself, that vast, messy, undrawable reality they're trying to describe.
And this diagram right here, this is going to be our guide for that whole journey. You can see on the left, we're starting with reality. Then we move through the human perspective and end up all the way on the right with a scientific model, something just labeled paper. So let's break down how we get from A to B.
So, let's start at the very beginning, the territory itself. In this model, this baseline reality is called C-space, which is really just a concept for the universe before we've tried to chop it up or put any labels on it.
And look at how it's drawn here. It's not a bunch of separate little dots or things. It's this dynamic, interconnected web. Seriously, think less like a box of billiard balls and more like a single, giant flowing river. In this picture of reality, there are no separate things at all. It's just one big, unified system. And this is the absolute key takeaway for this first part. In this model, reality, at its most fundamental level, is a unified whole. Every single division we see, every object, every boundary, it doesn't actually exist out there for us to find. It's something that we, ourselves, create later on. So, how do we get from that seamless, undivided whole to the world of separate objects that we all experience every day? Well, the very first cut into reality isn't made in some high-tech lab. It's made by our own minds.
The second we decide to observe something, we make the very first split. The moment you choose to focus on a thing, doesn't matter if it's a particle detector or just the coffee cup on your desk, you are conceptually carving it out from everything else. You create a division between a subject and an object.
And this is what the model calls separation A. And the most important word there is perceived. This separation isn't real, not in an absolute sense. It's an act of consciousness. It's like when you're in a crowded room and you pick out a single voice to listen to. You are creating a distinction so that you can focus and make sense of all the noise.
Okay, so our perception makes that first kind of fuzzy cut. But science needs to be way more rigorous than that, right? This is where we move from our subjective viewpoint to a formal objective model, the world as it exists on paper.
So now we're in the paper domain. This is where scientists take our messy, real-world perceptions and build these clean, abstract mathematical models. And to make a problem actually solvable, they have to draw really sharp lines, defining exactly what's in the model and, crucially, what they're choosing to ignore. This leads us straight to separation B. So inside this abstract model, on paper, a very clear line is drawn. It's between the instrument doing the measuring and the specific particles that are being studied. It's a formal, necessary step to isolate the pieces of the puzzle.
And finally, we have separation C. This is all about defining the boundary of the entire experiment. For example, a physicist might be studying a particle collision. That's separation B. But they also have to make a conscious choice to ignore, say, the gravitational pull of Jupiter. That's separation C. Drawing these lines B and C is what makes the math work. It's what makes calculation even possible.
So let's just step back for a second and put it all together. Let's look at this whole journey from a bird's eye view. We start with this unified, messy reality, and through a series of very deliberate cuts and separations, we build a structured, clean, scientific model.
And this cable just lays it all out, nice and clean. You've got reality or space with zero separations. Then, the human perspective comes in and introduces that first perceptual cut, separation A.
And finally, the scientific model on paper formalizes everything with 2 more cuts, separations B and C. The whole journey is just one of increasing division for the sake of understanding.
So, the crucial point is this. Science, from this point of view, doesn't just discover pre-existing lines in the fabric of reality, it actually creates those lines. It draws those boundaries for the purpose of making sense of it all. We have to impose a structure on this seamless whole just to make it intelligible to us.
So what does all of this mean for quantum mechanics itself? I mean, if the theory is built on top of all these separations that we ourselves create, then what exactly is it? Just let that sink in for a second. We spend so much time and energy arguing about the interpretation of quantum mechanics, but what if we've been looking at it completely backwards? What if quantum mechanics isn't some mysterious description of reality that needs us to interpret it, but instead it is the very framework of our active interpreting reality? It's not the map, it's the rules for how we're allowed to draw the map in the first place.
And that leaves us with one final, absolutely fascinating question. If our best scientific theories are maps, our interpretations, then what is the territory that we're all trying to interpret? It points us right back to that undivided, seamless reality, that C-space, reminding us that underneath all of our beautiful equations and our incredible models, there is a hole that might just be fundamentally beyond our ability to separate, and therefore, maybe beyond our ability to ever fully know.